Okay, day 2. We are going to look at dichotomous keys and phylogenetic trees. I'm just pulling up the PowerPoint that is for today's lesson, and then I will present it. So you have this note for those of you who were there on the last day. I did hand out this note as well. If not, I don't think you have to write too much down. Just try to get a general understanding of it because you will do a gizmo when you're completed this. Okay, so it's ready to go and I'm going to present it. Tab. Here we go. Perfect. Okay, so dichotomous keys and phylogenetic trees. So first one, classification. So we looked at some classification yesterday, right? We looked at taxonomy, which is a way of naming. It's a nomenclature, right? It's a naming system. So what this is looking at is a way to look at specific things or find what you're looking for. So this is, would it not be annoying to look up someone's phone number and have to analyze each listing until you came across the one you were looking for? A phone book or 411 is a way of classifying information about phone numbers and addresses. Now, you guys probably don't, I don't even know if you would know what 411 is, or a phone book actually. Like they don't make the phone books really anymore. They used to print out a new phone book for everyone in Barrie once a year. I think we got a new one in the mail, and it was huge. It was so thick, and everyone's numbers would be in there, and you could find them alphabetically. So you would look for someone's last name in the phone book and you could find them, and it would also give their address, right? So you had all this information for everyone in Barrie at your hands. Now they don't have that because no one has home phone numbers anymore. Everyone's phone number is a cell number, and a lot of them are not even, public, so people don't have access to these numbers. But that was a way that you could find someone's phone number, right? Just by knowing their last name. So taxonomy is the science of naming. So we talked about that yesterday, identifying and classifying species, right? So we've looked at one form of classification, which was that, and it was called binomial nomenclature because you would get the two different names, right? And binomial nomenclature is a system of classifying living things. That's what that was. So we classified living things within their 7, using the 7 different levels of classification, right? So your kingdom, phylum, class, order, family, genus, and then species. So there's 2 other ways of classifying organisms, one being your dichotomous keys and one being phylogenetic trees. So first, we're going to look at dichotomous keys. I think this is the easier of the 2. The dichotomous key is used to classify unfamiliar organisms by posing a series of questions about the organism in question. And each question asks the user to choose between 2 potential characteristics the organism may have. Okay, so let's look at an example. All right, so here's a dichotomous key. So if you were to draw a card out of the deck, there's 52 cards in a deck. So you draw out a card in a deck, and I say, okay, so is it black or red? And you would say red. Okay, and I would say hearts are not hearts, like hearts are diamonds, but like hearts are not hearts. If it was a heart, you'd say heart. And then it'd be picture card or number card. You'd say picture card. Is it female or male? Well, it's female. Well, then it's Queen of Hearts. Okay, because the king and the Joker are both males. Okay, so that's a way to distinguish between what card it is. Okay, this is all what a dichotomous key is. It's asking you 2 questions. Is it this or is it this? And you have to pick one of them. Okay. All right, so example of Pokemon. Okay, we're just going to skip that. We're going to go right to this Pokemon one. Okay, so you have these 8 characters. Okay, we don't know what their names are. So I bet you some of you do. I'm sure some of you did Pokemon growing up. I have no clue what any of their names are. But say you were looking to find out their names, and so you'd go through these questions, okay? So let's pick a character. So let's pick this first guy here, this yellow guy here. Does he have less than 2 appendages, or does he have more than 2 appendages? Well, he has more. Okay, so go to step 4. Whoop, go to step 4. Inhabits terrestrial environment, inhabits aquatic environment. I have no idea, but what I'm going to go with is the fact that he has legs, and this guy both are swimmers. Okay, so because this guy doesn't have fins or anything, I'm going to say he inhabits terrestrial environment. Okay, so go to step 6. Whoop. Does he have wings? Does not have wings. Doesn't have wings. So go to step 8. Whoop. Has electric powers, has fire powers. I have no idea what powers he has because it doesn't show me. But what I do know and what I can figure out is because I'm super smart, just kidding. But what I can figure out is this guy would have answered all the same answers to this one. He has more than 2 appendages, does not have wings, terrestrial, so and so on. So he's got all we would have answered yes to all those same ones that we answered to this guy, but this guy has flame on his tail, which tell me he probably has the firepower, which would mean he would be Charmander, and this guy would have electric powers, which means he would be Pikachu. Okay, you see what we did there? Just going back and forth between 2 questions, and then you get your answer when you figured it out. Okay. Go back, and obviously there's 2 of everything here. So round in shape is not round in shape. Well, these 2 are round. These 2 are the aquatic guys. These 2 are winged. Okay. And you'd be able to answer all those. Now going down. And then, oh, look, there's the answer key there. So if you wanted to go through it and then check out your answer key, that's great. All right. So these are phylogenetic trees. Okay. These were used more to find out our background, as in like our ancestors. Okay, this is where these were developed. Okay, so phylogeny is the evolutionary development of a group of organisms. So biologists use phylogenetic analysis to compare living organisms to extinct organisms to see what traits we have in common, right? Because again, that whole science background is evolution, right? We're evolving, we're constantly evolving. We've evolved from apes, right? We've evolved from aquatic animals. So these are things that we've evolved from. So we have the appendix because we evolved from apes, and we used to eat a lot of grass and bark, and that's what appendix used to help us digest it. Now we don't need the appendix anymore. And so on. Okay. Phylogenetic trees group organisms based on a shared common ancestor, right? So based on our past. That's not always the case, okay? But to create a phylogenetic tree, scientists consider the following. They look at fossil records, similarities in both morphology and physiology, which is more what we do now because we can look at morphology and physiology. Most of us can't look at the fossil records. And then our DNA. So how these phylogenetic trees are is an outgroup. So something that we it's like an outlier. And then we're going forward from that. So in this case, Lancelet is our outgroup, okay? So it doesn't have any of these characteristics. So we start with this one. And then our first characteristic we're going to look at when we're looking at these, because you need to have an outgroup that's your starting point, okay? So it's before we bring in the characteristics. So it has none of these characteristics. The Lancelet doesn't have anything above here. So first characteristic we're going to pull out is vertebral column, okay? So all of these going forward now have a vertebrae. This Lancelet does not, but everything else does, okay? So they all have a vertebrae. So then the next one we're going to pull out is jaws. What has a jaw? Jaws, not the movie Jaws, but who has a jaw? Okay? The lamprey does not. So that's why it's here, okay? So you need to pull in a characteristics where it's going to start to wean out some of these. That's the whole purpose. So this guy doesn't have a jaw. Next one we're going to look at is 4 walking legs. Well, the tuna doesn't have a walking leg. That's why it's on this side. Okay. Amniotic egg. Salamanders don't. That's again why it's on this side. And then to distinguish between the last two, because they have everything else in common, hair. Turtles don't have hair, leopards do. So there we go. So it's just a way of weaning things out based on our similarities. Okay? So scientists, to develop a phylogenetic tree, they choose a group. Again, yesterday we talked about the term taxa. So a group to be analyzed, or taxa. For each member of the group, it determines some observable traits, and we note their states. Okay? For each trait, determine which state is ancestral and which is derived. Okay? So what came from the past and what did not. So this is usually done by comparison with a more distantly related organism, turn the outgroup. So that first one that we looked at, that lancelet, that was the outgroup, more distant related. So way back in the day. And then our group taxa by shared derived character states. Okay. So phylogenetic tree. So it's showing here, this chart here, our character table, is showing us all of the characteristics that each of them have. Okay. So all 5 of them have this vertebral column. Our outgroup, our lancelet, does not. Okay. So this is a very distant relative organism. But since the lancelet, we've developed, maybe we've evolved to have a vertebrae now. Okay. And then we evolved to have jaws. We evolved to have walking legs. Then we evolved to have these amniotic eggs. Then we evolved to have hair because of the temperature, right? That's what's showing you here. Okay. And that's what a phylogenetic tree is. We may not look at these again. We may when we're back in class. Who knows? But for today, we're focusing on the dichotomous key. Okay. So with the dichotomous key, you're going to, I'm just going to stop sharing that. And we're going to go and we're going to look at now back to our D2L. Okay. So what you're going to be working on now is you're going to work and complete this silly science worksheet. So it's just our dichotomous key. So practice doing this one. Okay, your silly science. And then you're going to go and you're going to do our gizmo, which is posted here. Or if you were at school, I gave most of you this dichotomous key at school. Okay. So it's a long one. So this is the one you're going to be working on for pretty much your whole class time today. So this is getting submitted into Dropbox. Okay. You're not submitting the silly science worksheet. You're just submitting this dichotomous key into Dropbox. I made a folder. Okay. There's your dichotomous gizmo folder. Okay. So you will be submitting that in there today. So that's it. That's all you're going to be submitting today is your dichotomous key. Okay. So if you have any questions, you can ask me. Pop into Google Meet. But it's only the dichotomous key that you're handing in today. And then that is it for the lesson.